So hello everyone, and I'll be starting this section very soon. It's almost 4 p.m. I try to start as close to 4 p.m. as possible so that I get the full 40 minutes rather than having to be cut off at the end. So before I start, I'll just say if anyone has any doubts over the past long weekend, since you had some time to think about what we did, if anybody has any questions, I'll be happy to answer them before we start this day's session. All right. So I think it's time, and I would like to get started. So where we stopped off, at least last week, was where we had applied this function to this group by object, right? So the idea, what I actually said was that initially we had seen that we can apply the mean to all of them. That is, if you want to calculate, let's say, you want to calculate the mean of global sales, North America sales, and the year for grouping by names, that can be done, right? So for example, if we say VD df dot group by mean, and to this we just apply mean, or even if we select these columns and we apply mean, so I could further select NA sales, global sales, and year. Oh, I'm sorry, we have to actually import everything. Import numpy as np, import pandas as pd, and now I will read my file. And now I can run this. So you see, we get this result. But the problem with as I said, what the result is that it makes perfect sense to find the mean of North America sales, global sales. However, it doesn't make much sense to calculate the mean of the year, right? Because finding the mean of the year doesn't really make much sense. If you want to give it a single number for every row, then either it makes sense to take the minimum or the maximum or some other function, right? So with the idea of this, that is, we thought that how about we combine the functions on these columns. So let's say, for example, I want the mean of North America sales and I want the mean of global sales, but I want the minimum of year. Now then we saw that we have to then try to create our own function. So we came up with this function and we found that we can apply the function, and in exactly the same way the apply works for a normal group by method, the group by also creates, in such a case, a similar collection of rows, right? So apply then takes a collection of rows, which means a data frame, and for this each data frame we are returning back a series. So the end result is we get a series, and we saw that this is the series we got. The only problem we saw was that we had seen, and let me just go and write it again. Let me call it this name, and then let me paste it again. So if, for example, I paste this, now I'm applying the method, right? So now let's count how much time it takes. Notice how much time it's taking. That took a long time. We get the result, but it took a long time. Now, if I rerun this command again, you see how much time it took. All right. Can anyone comment on this? I think I already gave the answer, but can we just have a quick discussion on this again? So as I said, the main reason for this was because we are creating a series object, right? That is the main reason. For each collection of rows which group by is putting together, we are calculating the mean and the minimum, but then we are creating a series object. When you create a series object, Python has to create the data, has to create methods, has to create attributes, has to create a lot of things every time you just create this object. So if we have 11,493 rows, we are creating 11,493 such objects every time, right? And that is the reason why it's taking so much time. It's taking almost 8 to 10 seconds, right? Here, we are not doing that. We are not calculating. We are not creating an object every time, right? It happens under the hood. That means Pandas deals with it much faster, right? So this is the reason why. So at this point, I'll just stop for a minute. Does anyone have any doubt about what I just said? So to carry on, I mean, I hope everyone's able to hear me.
Yes, yes.
Okay, fine. So to carry on with this method, now what I'm going to do is, how do we solve this problem? Now, there are several ways, and I'll talk about it, but the main reason I wanted to show you this is that sometimes writing your own function may not be the best idea. And this is the reason why I would say in data science, always look if there is an inbuilt method or something where you do not have to write your own methods, right? Because when you write your own methods, you end up creating these objects which eventually slow down your calculations. All right. So the simplest way to solve this problem is a brute force method. For example, all we have to do is just say, let's say, we'll say new df. Let's call it new df only. And you just say, let me just copy this part, that is pddf name. And to this, we can just extract. So here we had done this vddf name, that is a group by name. So to this, I'm going to extract NA sales, global sales. And I'm going to calculate the mean of this. So if I look at what new df is, it is just 2 columns. That's it. All right. Now, what about the third column? For the third column, all we have to do is we just have to calculate this one column separately. So instead of specifying this, I'll just copy it to make it faster. I just need one column. So all I have to do is say year, and instead of saying mean, let's say take max, right? So year df is just a single, is exactly the same structure, right? If you look at the structure here, 11,493, but this is a series. Now, how do I mix these two? All I have to do is just add this series to this data frame. So all I have to do is just say new df year is equal to this one, year df. and now this is my method, right? So eventually I get the same result. Now, the only problem with this method is, as you can of course see, that you have to break it up into different steps, right? This eventually leads to 2 or 3 steps. Now, the problem is, so far, we haven't seen the negative side because we are dealing with eventually only 12,000 rows. As I said before, in data science, later on, you will see quite often, you'll be dealing with millions, if not billions. Now, when that happens, this kind of calculation makes a difference. If you're going to create billions of series objects each time, right, then you might end up taking hours, maybe even, I don't know how long amount of time before it actually gives you a result. But if you use something like this, your results are going to be much faster. All right. So at this point of time, I'll just stop for a minute. Does anyone have any doubts about what I said? Okay, no doubts at all. Okay, so in that case, before I talk about the next stage, that is in the next main major operation that we got to start doing is joins. But before I start talking about joins, I would like to talk about one other thing which so far we didn't look at. That is, how do we write functions, right? So, like for example, let's take this one function itself, right? We were returning a pd.series, right? So let's just quickly do something else. For example, let's take the usual data frame, and we had calculated before the ratio of North America sales and global sales, right? We had done that before, or North America sales and other sales. So let's just repeat that. So for example, let's say calculate ratio x, and we were returning x of NA sales divided by x of other sales, right? This is what we were doing, and here we were applying this to this data frame, right? So we were saying apply, and we were saying giving this function with an axis is equal to 1, right? And what we were saying is that this video df is a new column called ratio. This is what we had done. Okay, this is something which we had done several lectures before, but I'm just revisiting it. So now what this does is, oh, apparently there is a divide by 0 error. Okay, so what I need to do is, if then return, else return 0. Okay, so now if we look at video df, we get this last column called ratio, which is basically the ratio of North America sales to other sales, right? So at this point, I'll just stop for a minute. Does anyone have any doubt about what we did? This is just a sample calculation. Yeah, go ahead.
And you're setting axis 1 because?
Yeah, because remember, like I said, we have a video df, which is a data frame. If you're sending a data frame to the apply method, then we have to give axis is equal to 1 to be able to extract the columns when in the function, right? So like for example, you just go into the help. You see, normally its axis is equal to 0. So if you do not specify axis is equal to 1, it will iterate only through the rows of the data frame. Now, we have already talked about this. For example, if we remove this, right, and we run this, to begin it gives an error. The reason why it gives an error is because you can't access X the same. You cannot access the columns exactly the same way because it is not looking for columns.
Okay, got it. Thank you. Thank you.
Any other doubt? Okay, so now going ahead, there is nothing wrong with this. This is perfectly okay programmatically. But the problem is this. In data science, whenever you write any kind of query or you do computations, you should usually try to do it in as little number of lines as possible, right? So for example, this function is actually a very simple function, right? It actually is extremely simple. So now the question is, if you want to apply such a function, it is usually desirable that you use a Lambda function so that the entire thing just is one line only. So now the question is, how will I apply a Lambda function? So let me just go and copy this here. So in a Lambda function, first and foremost, how do you write a Lambda function? First and foremost, take this DEF. The DEF becomes Lambda. Because remember, just the way you're defining a function, a Lambda function is called Lambda. The next is a Lambda function does not have a name. So you delete the name, right? Because a Lambda function is an anonymous function. The next, there is no parenthesis around the argument. After Lambda, there is a space, then there is argument. You can have multiple arguments as well, right? But in this case, we have only one argument. After the argument comes the return. You are directly returning. So how will you do the return? What happens is you specify the return, but you do not mention return. Return is deleted. All right. And you write the other stuff as it is. So for example, all I have to do is copy this. This is my Lambda function. Does anyone have any doubt about what I did? This is exactly the same as what we did before, right? So let me just execute this and we'll talk. And you see this exactly the same result. So does anyone have any doubt about what I did? Let me give you another simple example. So like for example, and this is one of the reasons why I wanted to talk about this, because when you go, I'm assuming that at some point of time, many of you will be going for data science interviews because you'll be applying for jobs. When that happens, and if they ask you to write a query, then you should try to write a query in as little lines as possible. So like, look at this. This is a one-line query, right? We have produced a result with just one line. And this is what they like to see. They want to see you create queries or rather do computations in as little lines as possible. So let's say I'll create another simple function. Let's say some function where let's say I take X, right? And let's say I want to do, let's say I say Y is equal to X plus 10. All right, doesn't matter what I'm trying to do, just very simple. Or rather than X, let's say multiplied by 2. That's easier, it's better to understand. Multiplied by 2 and return Y. Now, let me try to do this on the North America sales. DF apply Actually, let me just take North America sales. Dot apply, and let me copy this function. Now there is no need to put the access argument because there is only one, right? So if I do this, I will get the multiplication of North America, right? This is what I will get. So let me just give it another name. Let's say x, this is x is equal to, and let's look at x, and let's look at North America. So you see here, we are multiplying in North America sales every time, right? Does anyone have any doubt about what I did? Just a sample function. Okay, so how will you write this as a lambda function? Again, same thing. DEF gets replaced by lambda. When you say DEF, you're defining a function. When you say lambda, what comes after this is a lambda function. In a lambda function, we do not have a name, so you delete the name. Also, you delete the parentheses around the argument, right? After this, you must have only one line, and that one line must be the return. So we combine this into one line, first thing. So return y is equal to x into 2. So we can combine this into just one, right? So we are crunching the number of lines of the code. Now that we have this, we can take the return value and place it here. Only one difference, a lambda does not have a return statement. So you delete the return statement. So this is the lambda function. That's it. This is exactly the same as this one. So does anyone have any doubt about what I did?
I have a doubt.
Yeah.
Yeah, how is this faster than writing a normal function? Because at the end of the day, if we're going through so many entries, it will be the same, right?
It's not so much about entries. It is about what you call visual, or rather aesthetics of code. So if you can actually write it in such a way, and instead you write it as a normal function, the problem is the chances of, or rather the way they perceive you, or the way the company perceives you, is going to be negative. That's how it is. So it's mainly, like I said, it is more about aesthetics. That is, usually they like to see, when they see a query, when they ask you to do anything like a computation or anything, they would like to see the entire query in as little lines as possible. Even if it runs the same speed, they would like to see it as little lines as possible. So which means if you write it and as something like this is going to create a much better impression than trying to do something like this.
All right. Okay.
This is more like a kind of an interview tip. Any other doubt? Okay, so I'll just run this. It should give you the same result. Yeah, same result. Now that we've talked about this, I would like to talk about one other thing, right? So before we go on, there's basically a few other tasks which we can do, at least with respect to basic data science. One of them is how to join data frames, and the other one is multi-index data frames. So the first thing is, let me talk about joining data frames. Now let's look at this data frame once. Right, so this is our data frame. Now, by the way, we have added this row, right? Rather this column. We've added this column called ratio. If you want to delete a column, you have to specify this thing called drop, right? So if I specify drop, just look at the help. This is what it says, right? So for example, you are saying that you're dropping something. You can specify a label. By default, the axis is equal to 0. You can specify a specific index, or you can specify columns, right? Most importantly, look at this. The in place is false. So let's try to delete this column once. So if I want to delete it, what do I say? There's one way. If I say ratio, this will not work, right? Because remember, we are now using positional arguments. We are saying labels. So if I say only ratio, it is taking the first argument. So which means it is taking it as a label. Now, when you say label, it is automatically looking at the index. So if I say drop, it will say error. Why? Because it is saying that ratio is not found in the axis. The reason, because remember, axis is 0. We are looking along rows. It doesn't see a row called axis. So there's two ways to do this. Either one, I can say axis is equal to 1. And now you see it has been deleted. But again, very important. If you go back and say video df head, it still appears. The reason why it appears is because in place is equal to false. In place is equal to false. The reason is because if in place is equal to true, it will delete the data frame there and then. Here it returns another data frame, right? So to solve this problem, you can say in place is equal to true, but I would just like to show you another way. Another way is, instead of saying axis is equal to 1, you just have to say columns is equal to ratio, and you get exactly the same result, right? So either you can say labels is equal to ratio and axis is equal to 1, or you can say columns is equal to ratio. So you can either you can explicitly specify the column, or you can specify a label and an axis, either way. So now that this is done, I will just quickly say in place is equal to true. And you see it has been deleted. So at this point of time, I'll just stop for a minute. Does anyone have any doubt about what I said?
Hello, sir.
Yeah.
Sir, that axis equal to 1 you have used in that input 30, I think.
Which, this one?
Yes.
Mm-hmm.
Sir, why we need axis equal to 1? Because we have only one column ratio. Here we don't have multiple columns. Why we need to represent axis?
Actually, the reason is because this is the default. Axis is equal to 0. So you see, but these are the default values. Labels is equal to none, index equal to none, columns equal to none, but axis is equal to 0. So if you do not specify an axis and we specify only a positional argument, so ratio here is a positional argument. So ratio means it is a label. And axis is equal to 0 if you don't specify the axis. So what happens is, since axis is equal to 0, it looks along the rows for a row called ratio.
Okay, sir.
Any other doubt?
Can I use this command if I want to drop an entry where there's a particular value? Like suppose I want to drop where any sales is a particular value. I want to drop that entry.
Oh, sure. So like, for example, okay, let's say, again, so here, in such a case, what I would suggest is like this. Let's say we have video DF. Let's say we have, okay, let's say for example, let me make it between 10 and 11. So video DF, NA sales, what do we do? If it is greater than 10, and you know how to do this, right? So video DF and we have to say and first let me see if I get anything. So there are 18 such rows where the North America sales, oh no, sorry, should be less than 11. Yeah, so you see there is only one game where the North America sales is greater than 10 and less than 11. Okay, so now the question is, how do we delete this? Isn't that, I think that should be your
Yeah, that's my query.
So what we have to do now is we have to now say now what do we get if we do this? We are getting an entire row, right? Now there's different ways in which you can do this. One is, let's look at the drop again here. You see the drop function specifies a label, an axis, an index, and a column, right? So we can specify any of these to get our work done. So for example, one way to do this is we can leave labels as it is. This is axis, right? So now the label, but this is not a label. Remember, this is an entire row. This is actually a data frame. So one way to do this is we just say index. And this will delete number 21, right? So for example, let's say I'll just take it as X, right? Right, this is X. So video DF, iloc, I have only a few minutes left, so I probably will finish off after this, 25. So 21, was it 21? Yeah, Super Mario Land. So 21, number 21 is this game which satisfied that requirement, right? So now let's look at what we get when we do X iloc 025. And now you see 21 doesn't have that value. Right? Of course, the main problem is we've deleted, actually we have taken only North America sales. So which actually is an interesting question. Why is it only this dropping any sales? All right, so I think let me just figure this out because we are almost out of time, but I think I partly answered your question. Do you get what do you see what I've done?
Yeah, I
Yeah, it's
understood.
just
Thank
I
you.
am trying to figure out why it has actually returned back a series. So I just have to figure out why this particular thing returns back a series rather than actually giving back the entire data frame. I'm going to think about what exactly it has done.
Yeah, the variable name is different here. Capital X and small x.
Oh my God. Okay. That I put the caps lock on. Yeah. Sorry. So that is what has happened. Okay. Yeah. So now if you go and look, you see 21 is gone. Yeah, okay. That was a silly mistake. I forgot that the caps lock got hit. Okay. Does that answer your question?
Yeah, thank you.
Yeah, good. Thanks for pointing out the X and the capital X and the small x. I didn't see it. Does anyone have any other doubt? We are almost about out of time. So if you have any doubts, please do ask, but I'll just try to close this session. So from the latest news, the lockdown in India continues till 3rd of May. In Germany, we are waiting for news about what the government will say. On the 19th is, I think, when they will decide what to do. So we will continue this week with this lecture series, and after that I will let you know whether I go back to the office or not, and how it works, whether even if my office may continue as work from home for a while, because we are not essential workers. So I don't know how it works. So if that does happen, then this will probably be like once in a week session, maybe on a Saturday.
Okay, got it.
So other than that, feel free to ask. Otherwise, we are almost out of time. I think we have maybe a couple of minutes left. Okay, so in that case, I guess we'll just say goodbye, because this, I think in the next session, we will look at we'll look at the join method, and we'll look at some other types of joins, like the inner join, the outer join, the left join, the right join. So this is also will be very useful when you want to combine two data frames together and sort of do it in just one query. So we'll look at that in the tomorrow's session. So see you tomorrow. Goodbye for now.
Bye.
Bye, sir.
Thank you, sir.